Okay, so let's practice calculating some wave stuff. So I've given you guys the equations that you need here. So we know that the velocity of a wave, right? So velocity is distance over time, can be found by taking the wavelength, which is also a measure of distance, divided by the period, which is also a measure of time. Okay, wavelength in meters, period in seconds, right? So meters per second, that's what velocity is trying to be in, right? That's the SI unit for velocity, meters per second. So we can also say that that's equal to wavelength times 1 over t, right? Like you probably have learned in algebra class, right? That what you have when you have wavelength over period, lambda over t, it's the same thing as lambda times 1 over t, right? Same exact thing. And we know that 1 over t is equal to frequency because we know, excuse me, sorry. We know that frequency is equal to 1 over period. Like we know that that is true. They're inverses of one another. And we also know that period is equal to 1 over frequency, in case you need to know that. So those things are true. Okay. So we know that that's how those things are related because remember, the period is how long it takes for a wave to go by, and the frequency is how many go by in a given time, right? So you can kind of inverse them. Okay. Not kind of, you definitely can. So let's think about how we can do some math, right? So if I'm looking for velocity, so how fast, wow, change colors, it didn't change. How fast is a wave moving if the wavelength is 2 meters and, excuse me, and the period is 10 seconds, right? Okay. So, what have we been given? We do this every time we do a problem, right? We're given the following: wavelength is 2 meters, and period, which is t, is, 10 seconds. So, what do? We know that velocity equals lambda over t. Oh, look, we literally have that information. So we just take 2 meters and we put it over 10 seconds. And so we get what's 2 divided by 10. You can simplify it into 1/5 meters per second, or here, let's write it as 1 meter over 5 seconds, right? So 1 meter over every 5 seconds, right? Can we make this into a decimal? If you want to do, we can. You could just write 1 divided by 5 meters per second, 1/5 meter per second, or we could use our handy dandy calculator to do 1 divided by 5, or you could know this, right? Because 1 is 20% of 5, and so then we could write 0.2 meters per second is our velocity. Boom, easy, right? That one was just plug and play. All we had to do was take the numbers, put them into the formula, and go, right? Let's try changing it up just a tiny little bit. Before we do that, though, I'm going to screenshot this because we want on the next page of this. Okay. Pop this in here. Here we go. All right. Sorry, there's a little bit of a mess there. I'll try to erase it really quick. That's out of order. There we go. Nice. Good. Okay. Looks good. Okay. So let's make the problem a little bit more difficult, shall we? Let's say then instead, so find velocity when lambda equals 3 meters and frequency equals 20 hertz. Shall we? Okay, so now we know. Sorry, we need to write down our givens. Let's do that first. Hello. There we go. Sometimes my program is a little bit laggy. Oh man, it's really killing me tonight. We've been given that lambda equals 3 meters and that frequency equals 20 hertz. Remember, hertz is just a measurement of frequency, right? I'm not going to walk you through the unit conversion. Just use it. It's fine. I'm never going to give you things that aren't this. Okay. All right. So here's the thing, though. We're going to change colors. Maybe we might change colors. There we go. Okay. So we know that velocity is equal to lambda divided by period. We don't have period, do we? But we know that 1 over period is equal to frequency, right? So we can change this formula to say velocity is equal to lambda times frequency, can't we? So we just plug in again. Velocity is equal to 3 meters. 3 meters times 20 hertz. There we go. Okay. And then that's just 3 times 20, which is 60. And the units are technically meters times hertz, right? So a hertz must be a 1/2, right? It must be, right? Doesn't really matter. You can end up changing this into 60 meters per second, okay? Because we know that a hertz is a 1/2, basically. Okay, so that's what we're going to go with. We're just going to roll with that. I'm not going to walk you through the why. I'm just going to tell you that that's how it should roll out. That's how it should work for you. Okay, so that's mostly as hard as it can get, right? So let's take this information and copy and paste it one more time, just to show you one more situation, right? So what if we have to solve for velocity? So what if the question says solve for, oh, sorry, not velocity. Let's say we solve for lambda if a wave, excuse me, computer, moves at 10 meters per second, and you see you see a new crest every 20 seconds. Okay, so what information have I just given you? I just told you this information. It moves at 10 meters per second. That's the velocity. So velocity equals 10 meters per second. And I told you you see a new crest every 20 seconds, right? Which means that every 20 seconds, right, we see a new crest. So that means our period equals 20 seconds. I need to make that S easier to tell the seconds. There we go, 20 seconds. Okay. So we also now have this equation, right, that we know because we've been using it this whole time. We know that velocity is equal to lambda, which we're solving for, wavelength, right, divided by period, right? And we know two of those three numbers, right? So we know that 10 meters per second is equal to lambda over 20 seconds. So how do we solve for lambda? We multiply both sides. Let me get my other color here. We're going to multiply both sides by 20 seconds. And 20 and 20 cancel. So we have lambda on the right, and we'll be left with 20 times 10, which is 200 second meters per second equals lambda. Seconds and seconds cancel. So 200 meters equals lambda, right? So you can just write 200 meters is equal to lambda. And lambda is our symbol for wavelength, right? So that's, I mean, that's basically how it can go, right? I could also ask you to solve for frequency, or I could also ask you to solve for period. Here's the key. If you know two of these parts, you should be able to get the rest. Okay. I could even say like, all right, we know the frequency, or sorry, we know the wavelength and we know the velocity, find the period, then find the frequency. When you have period and you have you can find frequency by doing 1 divided by period equals frequency. Same difference if you have frequency, right? Everything's right there in this information right here at the top. So much so that I'm actually going to take this, I'm going to put it on top of your document so that y'all can see it. Okay. I'm going to make it smaller though, because it's taking up a lot of space. And then I'm just going to ask you like 5 or 6 problems real quick. So good luck with that. See you on the other side.